Scientists at Nanyang Technological University (NTU Singapore) have developed a liquid window panel that can simultaneously block the sun to regulate solar transmission while trapping thermal heat that can be released through the day and night, helping to reduce energy consumption in buildings. The NTU researchers developed their smart window by placing hydrogel-based liquid within glass panels and found that it can reduce up to 45% of heating, ventilation and air conditioning energy consumption in buildings in simulations compared to traditional glass windows. It is also around 30% more energy efficient than commercially available low-emissivity, that is energy efficient glass, while being cheaper to make. The smart window is the first reported instance in a scientific journal of energy-saving smart windows made using liquid. Windows are a key component in a building's design, but they are also the least energy efficient part. Due to the ease with which heat can transfer through glass, windows have a significant impact on heating and cooling costs of a building. According to a 2009 report by the United Nations, buildings account for 40% of global energy usage, and windows are responsible for half of that energy consumption. Conventional energy-saving low-emissivity windows are made with expensive coatings that cut down infrared light passing into or out of a building, thus helping to reduce demand for heating and cooling. However, they do not regulate visible light, which is a major component of sunlight that causes buildings to heat up. To develop a window to overcome these limitations, the NTU researchers turned to water, which absorbs a high amount of heat before it begins to get hot, a phenomenon known as high specific heat capacity. They created a mixture of micro hydrogel, water and a stabilizer, and found through experiments and simulations that it can effectively reduce energy consumption in a variety of climates due to its ability to respond to a change in temperature. Thanks to the hydrogel, the liquid mixture turns opaque when exposed to heat, thus blocking sunlight, and when cool, returns to its original clear state. At the same time, the high heat capacity of water allows a large amount of thermal energy to be stored instead of getting transferred through the glass and into the building during the hot day time. The heat will then be gradually cooled and released at night. The NTU research team believes that their innovation is best suited for use in office buildings where operating hours are mostly in the day. As a proof of concept, the scientists conducted outdoor tests in hot environment at Singapore and cold environment at Beijing. The Singapore test revealed that the smart liquid window had a lower temperature, that is 50 degrees Celsius, during the hottest time of the day, that is at noon, compared to a normal glass window. The Beijing test showed that the room using the smart liquid window consumed 11% less energy to maintain the same temperature compared to the room with a normal glass window. Simulations using an actual building model and weather data of 4 cities, Shanghai, Las Vegas, Riyadh and Singapore, showed that the smart liquid window had the best energy saving performance in all 4 cities when compared to regular glass windows and low emissivity windows. Soundproof tests also suggested that the smart liquid window reduces noise 15% more effectively than double glazed windows.